Hello dear student, welcome to the another video of our course, that is Discrete Mathematics. So in this video we are going to see about the basic concept of subset, superset, power, proper subset and power set. So without wasting much of time, let's start our discussion. So first we are going to see the definition of subset. If set A and B are two sets and every element of set A is also an element of set B, then the set A is called the subset of B, and we can use this symbol to denote the subset. So uh, if A and B are two sets and every element of set A is also an element of set B. Here we need to consider the every element. So if the every element of set A is also an element of set B, then the set A is called the subset of B. So I am going to give you the example which helps you to understand the definition of subset in better way. So consider we have a set A. So set A have three elements, that is 2, 4 and 6, and we have another set, that is set B. And in set B we have four elements that are 6, 4, 8 and 2. So we can say that here A is the subset of B because every element of set A is also a part of set B. So we can say that A is the subset of B. So we can denote A subset B. So here 2 is also there in B, 4 is also there in B, 6 is also there in B. So if every element of a set is also a part of another set, then the set A is called the subset of B. Here we need to note that B is not a subset of A because here 8 is not present in set A. So in simple word, if A and B are two sets and every element of set A is also an element of set B, then A is called a subset of B, and we can denote subset using this symbol, or we can say that B is the superset of A. So I'm going to give you the another example. Here we have a set A, and set A have four elements, that is 1, 2, 3 and 4, and we have another set, that is set B, and set B have 4, 5, 6 and 7. Here we can't say that A is the subset of B because A is not a subset of B, because in A does not have an every element that is part of B. Here we have 4, but here we don't have 1, 2 and 3 in set B. If every element of a set A is also a part of set B, then only we can say that A is the subset of B. But here in example, A is not a subset of B because here we don't have 3 in set B, 2 in set B, only 4 is present in set B. Therefore, A is not a subset of B. So here another example I am going to give you. Let set A is equals to 2, 4 and 6, and we have another set, that is B, and in B we have a X element, and X is an even natural number less than 8. So in set B we have even numbers which is less than 8. So we have set B equals to 2, 4 and 6. Here set A is the subset of B as well as B is the subset of A, because every element of A is also part of B and every element of B is also part of A. So therefore A is the subset of B and B is the subset of A. If A is the subset of B and B is the subset of A, then we can say that A equal to B. So set A is also equal to set B. So these are the examples. Hope these examples helps you to understand the concept of subset. Now we are going to learn about the superset. So this is the definition of superset. Whenever a set A is a subset of B, and we say that B is the superset of A, and we can write using this symbol. So nothing but if A is the subset of a B, then B is the superset of A. So this is this simple as that. So for example, here A is equals to A, E, I, O, U, and we have another set B, that is A, B, C up to Z. Therefore B is the superset of A because B contain all the elements of A. So if a set contain all the elements of another set, then it is known as superset. Here B is the superset of A because A contained A, E, I, O, U, and B contained A, B, C up to Z. So these all elements are present in set B. Therefore B is the superset of A. So here I already told you, here A is the subset of B, that is A is the subset of B and B is the superset of A. So it is simple as that. So now we are going to learn about the property of subset. So first property of subset is every set is the subset of itself. That is very trivial. A is the subset of A and B is the subset of B. So every set is the subset of itself. And another property and very important property is that empty set is the subset of every set. So empty set means set which does not contain any element. So we can represent the empty set using phi or empty curly braces. So empty set is the subset of every set. So we need to remember this is the very important properties of subset. So we can say that the every set has empty set as subset. So the empty set is the subset of every set. So we can denote the empty set using phi or empty parentheses. So another property, so it is a very trivial, we have already used this notation to represent the subset, and this means A is the subset of B, and this is we have already studied in our previous slides. And this also means B is the subset of me, which means B contains A. So it is very simple, but these two properties is very important, and we are going to use this property in our upcoming slides. So now we are going to learn about the power set, which is very important concepts of subsets. So here the definition of power set is a set of all subset of a set. So power set is nothing but a set of all the subset of sets. I'm going to give you the example to clear this definition. So for example, let S is a set and we have S equals to A, B, C. So in S we have three elements, that is A, B, C. So we need to list out all the possible subset from this set S. So power set is nothing but all the subset of a set. So now we need to list out all the elements or all the possible set using these three elements. So power set can be denoted using this symbol, and this is the cardinality of power set. In our previous slide we have studied that empty set is the subset of every set. So first subset of this set S equals to empty set. Now we need to arrange this singleton set. That is, singleton set means set which contain only single element. So we need to create a set using this symbol, and first we need to create the empty set, which is the subset of this sets, and now A is the subset of this sets, and set another set B, only set which contain only B is also a subset of this set, and C is also a subset of this set. Now we need to make a set using two elements, that is A and B is also a subset of this set, A and C is also a subset of this set. Similarly BC is also a subset of this set as, and ABC is the last possible subset using these elements. So we have how many numbers of subset possible using 3 elements? We have 1, 2, 3, 4, 5, 6, 7, 8. So total 8 number of subset available using these 3 elements. So these are the list of all possible subset, and list of all possible subset are called the power set, and power set is denoted using this symbol. So power set is nothing but set of all subset of a set. So we have this set as we have 3 elements, and these are the possible subset using these 3 elements. So we have simple formula to calculate the total number of subset, total number of subset available, total number of subset using the total number of subset of a given set. So using this formula we can calculate the total number of subset. So this is the P as denote the power set of set, power set, and we have 2 to the power n number of subset. So we can, I'm going to give you the example to how to find the total number of subset. For example, we have a set, and this set contain 1, 2 and 3. So we have 1, 2, 3, total number of 3 numbers of element. First we need to find the cardinality of that set. So the cardinality of S is 1, 2, 3. So we have 3 elements. So here question is, example, for the given set as, how many members will the power set have? So we have here set A has 3 elements, that is 1, 2, 3. So cardinality of set is 3, and cardinality of set, and this is the symbol that is used to represent the cardinality of set. Cardinality of set means total number of elements present in a set. So we have 1, 2, 3, 3 numbers of elements. Now we can use, now we need to assign n equals to cardinality of set. So we are assigning 3 equals to n. So we know that we have this formula to calculate the total number of power set. So we have 2 to the power 3. So n equals to 3. 3 means total number of elements of a set. So 2 to the power 3, that is 8 number of subset will be in the power set of S. So the power set of S equals to, how many elements are there in a power set? We have total number 8 numbers of elements will be in the power set of S. So this is how we can calculate the power set of any set using this formula. And here power set of S equals to 2 to the power n. Here n equals to total number of element. Suppose we have 4 elements in a set. So we have 2 to the power 4 number of possible power set. And this is all for today's lectures. I request you to list out all the possible subset of this set and submit it by today. Thank you.